You can do it if you believe you can. Hi, everyone. In this video, I would like to go through the following major topics. State the general term. Find Tn, write the recursive formula, find the number of terms, expand and simplify, and of course, determine the sum. Now, before we go through all the examples in this video, I would like you to track your progress by putting either a check mark next to your examples, meaning you fully understand how to do that example, or you can put an X next to the example to note that you have no idea what is going on yet, and you're going to go back and practice one more time. And of course, the third case, the in-between case where you feel like you know it, but you still want to practice one more time. Let's begin. Example 1A. For each of the following sequence, state the general term. Use the general term to find the next three terms. So before we look at this example, you want to be mindful. You look at it and you got to figure out, am I adding or am I subtracting to get to the next term? And if that is the case, we call this the arithmetic sequence. So again, just make a note, if you like, that if you're adding or if you're subtracting to get to the next term, that's basically going to be arithmetic. Now, of course, if you're not adding, if you're not subtracting, but you have to multiply or you have to divide, this is what we called geometric sequence. So again, not to overstate this, if you're adding or subtracting, which requires a common difference, that is going to be an arithmetic sequence. If you're multiplying or dividing, that's going to be a common ratio, which means it's going to be a geometric sequence. Now, I'm starting with negative 3.5. You can write down A, or you can say T1 if you like. The first number is going to be negative 3.5. If I look at the next term, that's negative 1. If I look at the next term, that's going to be 1.5. So a couple of things you can think about. The first thing is you can pretend there's a common difference. If that is true, you can take any number minus the number before that, and you can say, well, what happens if I take a negative 1 minus negative 3.5? So in this case, again, I invite you to do some mental math. If you want to grab a calculator, that's fine. But negative 1 plus 3.5 is going to be 2.5. Now, to confirm this really makes sense, you're going to do it again. So let's say if I'm taking 1.5, I'm subtracting negative 1. Again, negative 1.5 plus 1 is going to be 2.5. So this signals to you this is definitely an example of an arithmetic sequence. And of course, technically speaking, to have a sequence, you should really have 4 terms, but in this example, we gave you 3, which is fine. So now we need to do the following. Find the general term, which really means you want to find Tn. So again, if you want to translate this, general term just means what is Tn. Now, I hope you remember for an arithmetic sequence, the general term, Tn, is going to be given by the formula a plus n minus 1 times d. What does that really mean? In this case, a, the first number, is negative 3.5. You copy n minus 1 in brackets. You're going to multiply by the common difference, which is 2.5. Now again, what happens when you simplify this? Tn equals to negative 3.5. I'm going to go back and draw the arrows for you. Again, if the arrows help you stay organized, please use them. N times 2.5 is going to be 2.5 n. Negative 1 times 2.5 is negative 2.5. This means the general term is given by the formula 2.5n minus 6. So again, they're asking for the general term. We found the general term. They're also asking for the next 3 terms. So there's a couple of things you can do. There's a shortcut, which I'm going to show you at the end. There's also the general method. If you want to find the next 3 terms, you want to find the 4th term, the 5th term, and the 6th term. And what that means is you're going to plug in for T4, for example, and the before. So you know, if you take 2.5 times 4 minus 6, again, you can grab a calculator. I'm going to do some mental math. 4 times 2.5 is going to be 10. 10 minus 6 is going to be 4. So that's the next term. To find the 5th term, same idea. You can take 2.5 times 5 minus 6. And of course, in this case, that's going to be 12.5 minus 6. That's going to be 6.5. Last but not least, to find term number 6, you can take 2.5 times 6 minus 6. 2.5 times 6, that's going to be 12, or not 12, it's going to be 15. And 15 minus 6 is going to be 9. So again, that's the longer way of doing it. Here's the shortcut. And I invite you to think about it like this. You know, if you go back to the original given, negative 3.5, negative 1, negative 1.5, in one sentence, you're adding 2.5. You're adding 2.5 to get to the next term. So if you think about 1.5 plus 2.5, that would have given you 4, which we knew from this answer. 4 plus another 2.5 is going to be 6.5, which we knew from this second case. And last but not least, if you take 6.5 plus 2.5, that's going to give you 9. So that's a nice way to double check that you're doing it right. So again, we found the next three terms, and we found the general term. Example 1b, again, for each of the following sequence, state the general term. Use the general term to find the next three terms. So the most important part is you have to recognize what kind of sequence are we looking at. So for example, the first number A, or you can say T1 if you like, that's going to be 64. But you have to look at the pattern and figure out, is this going to be geometric? Is it going to be arithmetic? Or is it going to be neither? So by inspection, if you think about 64, this becomes negative 32. And this is where it's a little bit confusing. For some students, they're going to say, oh, 64 to negative 32. This means I need to subtract, let's say 96. That's one thought, right? But if you continue with that, though, negative 32 minus 96 will not give you 16 and won't give you negative 8. So the second idea is you kind of go back and say, well, what about 64 multiplied by negative half? And that does give you negative 32. Negative 32 multiplied by another negative half will give you 16. 16 multiplied by negative half will give you negative 8. Now notice I said multiplied. For those students who are thinking dividing, here's the mistake. Do not write down, for example, the common ratio is, oh, I'm dividing by negative 2. This is not how you do it. So I want to be very clear. I'm not only going to show you how to do it right, I'm also going to show you what not to do. Common ratio means you're multiplying. So even though you might be thinking dividing by negative 2, you always say multiply, in this case by half. And again, to do this, you can grab any number, divide it by the previous number, or any term divided by the previous term. So you can say negative 32 divided by 64, which will give you negative half. Again, if you do it one more time, and it could be any two numbers, let's say these two numbers, again, the common ratio is going to be negative 8 divided by 16, which is going to be negative half. The fact that you did a choice confirms it is definitely an example of a geometric sequence. Again, what does that really mean? My goal is to find the general term. Don't forget, Tn is A times R to the power of n minus 1. In this case, A, the first number, is going to be 64. R is going to be negative half to the power of n minus 1. And I think this is good enough in terms of the answer we're looking for. I'm going to put a box around this. Now, what I'm saying is good enough is because ideally, if you think about 64, you could kind of keep going and express it, as a power of 2. You can even break down negative half as a power of 2 and so on. But I'm going to just keep it as is, which is fine. So again, what about the next three terms? Your goal is to find term number 5, term number 6, and term number 7, which we're going to double check again. So the longer method is you go back to the formula and replace n with 5. Again, you can grab a calculator. I'm going to do some mental math. This is 64 times, in brackets, negative half to the power of 4. So that's going to be positive 4. If I find T6, again, I take 64. I multiply by negative half to the power of 6 minus 1. That's 64 times negative half to the power of 5. And if I look at this carefully, this should be negative 2. And of course, to find T7, I take 64 times negative half to the power of 7 minus 1. So that's negative half to the power of 6, multiply by 64, which I think the answer is 1. Again, what I'm going to say is double check by looking at the original row, 64, negative 32, 16, negative 8. Remember, you're multiplying by negative half. So if I take negative 8 times negative half, isn't that 4, which we knew from the work at the right bottom corner. If I take 4 times negative half, that's negative 2, which we knew again. And of course, negative 2 times negative half is going to be 1. So we found the general term. We found the next 3 terms. Example 2a. Find a and d, and then write the formula for the nth term Tn of arithmetic sequence with the following terms. Now I'm going to circle the most important idea. If we don't tell you whether it's geometric or arithmetic, you can't really do this because we won't know, right? So again, in a different color, this is the most important idea. Because we're telling you from the given, this is going to be an arithmetic sequence. Now you can say, oh, arithmetic. I remember an equals to a plus n minus 1 times d. Again, I'll write it one more time. Tn is a plus n minus 1 times d. Let's erase this. Let's write it better for you. I want to make sure you can see all the subscripts and all the terms. I'm going to draw a line in the middle, divide this into 2 columns. Now, if I go back, again, I'll color code this for your reference. T4 is going to be 12. In one sentence, the 4th term is going to be 12. What does that really mean? T4 is going to be a plus 4 minus 1 times d. Remember, T4 is going to be 12. And 4 minus 1, of course, is 3. So again, 12 equals to a plus 3d. In a different color, T11 is negative 2. So if I plug in 11, that's going to be a plus 11 minus 1 times d. Or negative 2 is going to be a plus 10d. Again, what's the goal here? Your goal is to solve for a and solve for d. Once you have a and d, you write down the formula, Tn. Now, there are many ways of doing this. I would say the fastest approach is to copy 12 equal to a plus 3d underneath. And of course, what you can do is you can subtract. When we solve by elimination, a minus a becomes 0. Again, on the left-hand side, negative 2 minus 12 is negative 14. On the right, you have 10 minus 3, which is 7, times d. The opposite of multiplying by 7 is to divide by 7. So d is going to be negative 14 divided by 7, negative 2. I go back, I'm going to solve for a. Again, 12 equals to a plus 3 times negative 2. So hope you can connect this. 3 times negative 2 is negative 6. Bring it to the other side. 6 plus 12 is going to be 18, just like that. Now again, this means we can write down the general term. Tn equals to a, which is 18, plus n minus 1 times d, which is negative 2. When you expand all this, again, I'm going to draw the arrows. If the arrows help you stay organized, please use the arrows. Negative 2 times n is negative 2n. Negative 1 times negative 2 is 2. This means the general term, Tn, is given by the formula negative 2n plus 20. Now, I'm going to over-deliver, everybody. This is not something that you need to do. I'm strongly recommending this because this is how you get perfect. So let's say you did this and you're thinking, well, I don't know if I did it right. I feel like I did it right, but I don't really know. So I would say in math, don't base it on feelings. You want to double check. How do we do that? Well, we already know T4 is supposed to be 12. So if I plug in 4, I should get 12. If I don't get 12, I go back, I do it again, right? So I plug in 4 in this case. And again, negative 8 plus 20 is exactly 12. And if you do it one more time, let's say for T11, I'm expecting T11 to be negative 2. And if I plug it back in, that's negative 2 times negative 2. Negative 2 times 11, I mean. Let's try again. Negative 2 times 11 plus 20. And again, that's negative 22 plus 20, which is negative 2. And the fact that these numbers match the given, now you know with confidence you did it right. Example 2b, find a, r, and tn for each geometric sequence. Again, you're given t2 to be negative 6, t5 to be negative 162. Step 1, again, this is the key right there. Geometric sequence, write down Tn equals to a times r to the power of n minus 1. I'm going to do it one more time. Tn equals to a to the power of, a times r to the power of n minus 1. I'm I'm going to draw a line in the middle, divide this into two different columns. Again, for your reference, I'm grabbing two different colors. T2 is going to be negative 6. This means the second term is negative 6. T2 in this example means a times r to the power of 2 minus 1, or you can say negative 6 equals to a times r. And we're going to come back to that in a different color. Again, T5 is negative 162. So the fifth term is going to be a times r to the power of 5 minus 1. ar to the power of 4 equals to negative 162. Again, in this example, we're not subtracting. We are dividing. So a note that you can make is anytime you have geometric, think dividing, right? Like if I went back to the previous page, I'm just going to write in the idea. When it's arithmetic, then you want to think subtracting. Think subtracting. But when it comes to geometric, think dividing. What do I mean by that? You can copy negative 6 equal to AR underneath, and we're going to divide now. Now, when we divide, it really means the following. I take negative 162 divided by negative 6, which equals to A times R to the 4 divided by A times R. Again, you can use a calculator, you can use mental math, but negative 162 divided by negative 6 is going to be 27. A divided by A is going to be 1. R to the 4 divided by R to the 1 is R to the power of 3. Again, I hope you can see the opposite of R cubed is you take the cube root. Now, because it's the cube root, there's only one answer. There's not plus or minus. That's only when you take a square root. So if you take the cube root of 27, 3 times 3 times 3 is 27. So R is going to be 3. What does that mean? You can plug it back to here. So negative 6 equals to A times 3, which means, again, the opposite of multiplying by 3 is to divide by 3. So A is going to be negative 2. So we found A. We found R. We're going to go back and find Tn. So we're going to go all the way to here. Tn, again, is going to be A, which is negative 2, times 3 to the power of n minus 1. Now, one more time, I would like to add value to your learning journey. You want to feel confident, you want to feel competent, continue with this one last step. Again, this is called double checking. You know, T2 is negative 6. Doesn't that mean if I plug in 2, I should get the same thing? Let's find out. So again, if I take negative 2 times 3, that's negative 6, which is amazing because we expected that because that was the information in the given. And again, if I find T5, I'm expecting negative 162. I go back, I take negative 2, I take 3 to the power of 5 minus 1. Again, you can grab a calculator. I'm going to do some mental math. 3 to the power of 4 is 81. 81 times negative 2 is negative 162. Again, it's not a surprise because this is the right answer. Example 3. Write the recursion formula for the following sequence. 1, 1, 2, and 3. So again, you want to write it like this. See, these are the questions where you want to practice a lot, not just in this video, but also from your textbook and your homework and your handouts and so on. So if I express this in a column, I'm saying the first number is 1. The second number is 1. The next number is 2. The next number is 3. And you need a recursion formula. Recursion formula just means I'm starting with, let's say, T1 equals to 1. Okay. Well, what about the next part, right? How do I describe the next term using the previous term? Or how do I describe the next term with the next term and the current term and the previous term and so on? So let's say this in a sentence. If you can say this in a sentence, you can definitely write it in math. So one pattern I discover is I have 1, 1, and 2. Let's stop and think about that. 1, 1, and 2. Okay. How can I get 2 from the previous two terms? So somebody say, oh, 1 plus 1 is 2. I'm going to write that down. 1 plus 1 is 2. That's good. But what about the next one? How do we get 3? Well, somebody look at this and say, oh, 1 plus 2 is going to be 3. So even if you keep going, right? 1, 1, 2, and 3. If you predict in the next couple of terms, you may say, oh, but 2 plus 3 is going to give you 5. 3 plus 5 is going to give you 8. 8 plus 5 is going to give you 13. 13 plus 8 is going to be, and you can see the pattern continues. So that is the pattern. Now the question is, how do we write this in math? So again, you can write down T1 is going to be 1. You can even say T2 is going to be 1. So those are the given. Now, what about Tn? So define any general term. Let's go back and talk about this. You see, to find T3, right? Isn't it true that T3 was found by taking T1 plus T2? I want to make sure you can see this first before I write the general formula for you. So again, 1 plus 1 is 2. But in the general idea is you take the third term, which is the first term, plus the second term. So now, if you think about that in the general case, you can say, well, Tn equals to the previous term plus the previous term. I'll say it again, right? To find the next term, you take the previous term plus the previous term. So that's the formula. Now, of course, there's one more idea you need to write down, because how do I know where I start? So for example, can n be -5? Can it be 0? Can it be 1? No, it can't be any of the above. The minimum is going to be a 3. So you can say n is going to be greater or equal to 3. That's one way to do it. Some students write down n is greater than 2. That's fine. But n, again, is basically an element of integers, positive integers. So I'll just leave it like that. Okay, so again, that is the recursion formula for the sequence 1, 1, 2, and 3. And of course, the bonus question, which I'm not going to answer now in the video, but you can comment below. What is the name of this sequence? Example 4a, find the number of terms. 19, 11, 3, all the way to negative 229. Now, notice in this question, we purposely did not tell you if it's going to be geometric, if it's going to be arithmetic, if it's going to be none of the above. So before we even deep dive into this, you need to figure out, what is this sequence? So again, the first step is going to be A is 19. If you want to write down T1 is 19, that's fine. But again, you want to figure out from 19 to 11 to 3, how's that possible? So again, one idea is to look at it and say, oh, what if I took the common difference, any term minus the previous term? What happened? Or what happens if I take 11 minus 19? So in this case, that's going to be -8. All right, let's try again. What if we took the common difference to be 3 minus 11? Well, 3 minus 11 is also -8. So now we can say, oh, D is going to be -8. A is going to be 19. Again, this supports the idea this must be an example of an arithmetic sequence. But the question is asking how many terms, like find the number of terms. So again, what does that really mean? In one symbol, you're looking for n. To find the number of terms, you're looking for n. And you can totally find this because, again, arithmetic means Tn equals to A plus n minus 1 times D. Your goal is to find n. You have everything else. Again, please remember, Tn is the general term, or in this case, we call this the last term. So that last number, -229, is going to be Tn. So I go back, I plug it in, -229, which equals to A is 19. And of course, D is going to be -8. So now I can solve for n. Let me kind of draw some lines here to divide these ideas. So now, again, -229 equals to 19. I'm going to go back and draw the arrows one more time. N times -8 is -8n. -1 times -8 is 8. Let's collect like terms. 19 plus 8 is 27 minus 8n. Now, if you like, you can bring -8n to the left. That's positive 8n. You can bring -229 to the right, which is positive 229. And again, you can do some mental math. You can grab a calculator, but 229 plus 27 is 256. And of course, the opposite of multiplying by 8 is to divide by 8, and n is going to be 32. Now, I'm running out of space, but I need you to write down, and maybe I'll create a space on the right top corner here, I guess. I need to write down the final statement. So here's a text box. We're going to write down, therefore, there are 32 terms. So let me fit this in the right corner, right top corner, just like that. Now, ideally, you should write at the bottom, but again, I'm running out of space, but that's it. There are 32 terms. Example 4b, find the number of terms. Again, we're given 16,384, 4,096, and all of a sudden it becomes 1. So the question becomes, what kind of sequence are we looking at? So you go back to the beginning. Again, by inspection, the first number, A or T1, is going to be 16,384. And now you want to figure out, do I multiply? Do I, do I add? Now, this one's a little bit tricky because the way it's given, right? So we should give you more terms in general, but this one, what you're supposed to think about, and I hope you can kind of see this, is you're asking, how do we get from 16,384 to 4,096? So one idea would be to take the common ratio, which is any number divided by the number before, or any term divided by the previous term. This is going to be 4,096 divided by 16,384. And I think this is 1 divided by 4. Again, you can always double check if you like with a calculator. So you can say 1 divided by 4. Now, some students may prefer 0.25. So I'm going to say either 1 divided by 4. You can say 0.25. Either one is fine. Now, I do want to say the intention behind this is to give you a geometric sequence. So maybe I'll add that in, because this, I can imagine some students may think, oh, but I could also subtract or I could add, right, a certain number. But this is really intended for to be geometric. Okay. So again, what are we looking for? Number of terms. You want to find n. To do that, you go back and you write down Tn equals to a times r to the power of n minus 1. Again, be mindful. Tn in this example means the last term. Tn really means, the general term, but in this example, it's the last term. So again, you go back and you can write down 1, which equals to, if you take the first number, 16,384, you multiply this by 0.25 to the power of n minus 1. Now, you got to be very careful here, because this requires some skills. The first step, of course, is the opposite of multiplying by 16,384. So divide by 16,384. On the right, this is 0.25, so 1 divided by 4. Now, there's 2 ways of doing this. The method you want to think about in grade 12 would be to log both sides or ln both sides. But there's also a second approach, which is a little bit different. This requires a little bit of practice. You go back and you say, well, how can I get 16,384 using a power of 4? So you need to grab a calculator, try 4 to the power of some number. And that number should give you 16,384. So one example could be, okay, if I took 4 to the power of 7, that should give you 16,384. So again, 1 to the power of 7 will give you 1. 4 to the power of 7 will give you 16,384. Now, when you have the same base, you can equate the exponents. 7 equals to n minus 1. So n equals to 8, which really means there are 8 terms. So again, let's grab a text box and add this in for you. Therefore, there are 8 terms. Put it right there for you. Example number 5. Expand and simplified. 3x squared plus 2 divided by x in brackets to the power of 4. Now, you could definitely use something called the binomial theorem. That works. There's another approach which also works, and it looks something like this. If you have 3x squared and 2 divided by x, and it's to the power of 4, you copy this 5 times. So again, whatever the exponent's going to be, add 1. So in this case, since the exponent is going to be 4, you copy it 5 times. If the exponent was, let's say, 100, then you would copy this 101 times. But of course, that would be too much in terms of the manual steps. But anyways, you go back and you copy this 5 times. Now, what do we do with the exponent? Think about 4. You start from 4 and you count down. 3, 2, 1. If you're doing it right, by the way, you always end up with 0 every time, 100% of the time. You go backwards, 4, 3, 2, 1, and 0, just like that. Now, the second step is to understand the numbers from the Pascal's triangle. And again, if you think about Pascal's triangle, it looks something like this. And I hope you can kind of see this, right? You can say 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, and in row 4, 1, 4, 6, 4, 1. So again, that is what we're looking at. 1, 4, 6, 4, 1. So if the exponent is 4, the goal is to look at row 4 in Pascal's triangle. And of course, you got to be careful, right? Row 0 is there. So the second row of Pascal's triangle is known as row 1. This is why this is, row number 4. Now, if you go back, remember you're adding, so you put the plus signs. If this was subtracting, by the way, the signs alternate, starting with the first term, plus, then minus, plus, minus, all the way to the end. Now, here's the second step. I'm going to use some arrows. Don't miss this. Here's the most common mistake, everybody. I'm going to make the mistake here, then I'll show you how to do it correctly. So one student always writes down, 3 times x to the power of 6. There are two mistakes here, by the way. Let's talk about them. So first of all, this is not how you do it, unfortunately. Because, first of all, think about the fact that 3 to the power of 4 means 3 times 3 times 3 times 3. That's going to be 81. So that's the first mistake. You got to make sure 3 is to the power of 4, not just 3. The second mistake, of course, is x squared to the power of 4 means power to a power. So you multiply the exponents. 2 times 4 is going to be 8. So x to the power of 8. That's how you're supposed to do it. Anything to the power of 0 is going to be 1. So now you keep going. Now let's add in some steps in between for you. If I think about 4 times 2, that's going to be 8. And I copy x. So again, right now, I'm just saying 4 times 2 over x is 8 divided by x. Again, if I draw these arrows, I'm just going to add in the step for you. 3 to the power of 3 is going to be 27. X squared to the power of 3 is going to be x to the power of 6. I'll put some brackets around just like that. If I keep going, that's going to be 6. Let's put 2 brackets here. Again, don't forget to square each term. 3 squared is going to be 9. X squared is going to be x to the power of 4. And again, likewise, you square here and here. This means 2 squared is going to be 4. X squared, just like that. Now, if you continue, I'll just put it here, I guess. You have 4 times 3. That's going to be 12. X squared. I'm still going to put the arrows here. Don't forget, 2 times 2 times 2 is going to be 8. Divided by x to the power of 3. Last but not least, anything to the power of 0 is going to be 1. Again, 4, you apply to both the numerator and denominator. 2 to the power of 4 is going to be 16. X to the 4, just like that. Here comes the final answer. So we can copy, and maybe I'll put the arrow or the equal sign right there. So 81, x to the power of 8, you can copy. Again, if you want to grab a calculator, that's fine. 8 times 27 is going to be 216. X to the power of 6 divided by x to the power of 1 is x to the power of 5. If I look at the next part, again, you can take 6 times 9 times 4. You can do that in one step. That's going to give you 216. X to the power of 4 divided by x squared is going to be x squared plus. This is going to be 12 times 8. That's 96. X squared divided by x cubed is going to be 1 divided by x. And last but not least, of course, you can copy 16 divided by x to the power of 4. And there's the answer. So let me just put a box around it, just like that. Example 6a, determine the sum of the following series. So again, we did not tell you if it's going to be geometric or arithmetic. So you got to figure out which formula am I using? Well, let's go back to the beginning. Step 1, a is going to be 1. The next question becomes, am I adding or am I multiplying to get to the next term? Meaning, am I looking at a common difference or a common ratio? So if you did start with a common difference, you can say any number minus the number before that, or any term minus the previous term. So I could say 5 divided by 4 minus 1. Now, some students, they don't like 5 divided by 4. They probably, we write this as a decimal. If you prefer writing 1.25 instead of 5 divided by 4, that's fine. But the common difference is going to be 0.25. But is that really true? So you can try this again and kind of say, well, what if I took 3 divided by 2 minus 5 divided by 4? And again, if you prefer writing down 1.5 minus 1.25, that's fine. It's still going to give you 0.25. So now we know with confidence this must be an example of an, let's do this again. This is an example of an arithmetic series. What's the difference between a sequence and a series? Series means you're adding it up. You're finding the sum. Sequence means that you have a bunch of numbers separated by a comma. And again, we go back. Sum. There are 2 ways to find the sum of an arithmetic series. One of them, of course, is you can say Sn equals n divided by 2 times t1 plus tn. And of course, the second method I'll write down as well is Sn equals n divided by 2 times 2a plus n minus 1 times d. Now, they both work, right? I mean, this second one works pretty much all the time. The first one works only if you have the last number, right? So you go back and you say, well, I can't really use the formula yet because there's one thing that's missing. We don't have n. So we're going to go back and solve for n. And to do that, what you have to do is, and I'll put it at the bottom here, write down Tn equals to a plus n minus 1 times d. Again, to solve for n, you go back, recognizing that Tn, which is the last term, that's going to be 20. The first number is 1, plus n minus 1 times the common difference, which is 0.25. So now we can solve for n. And I'm going to go back and erase this in a moment. The moment is here. Maybe I'll just leave that there. And I'll leave this part here. So I'll leave the part d equals to 0.25. But everything else we could erase. Okay. So again, 20 is going to be equal to 1 plus 0.25 n minus 0.25. Again, if you didn't catch that, you can draw the arrows just like that. And I'm going to continue here. So again, 20 equals to 0.25 times n. 1 minus 0.25 is 0.75. Don't forget, you can take 20 minus 0.75. That's going to give you 19.25, which equals to 0.25 times n. The opposite of multiplying by 0.25 is to divide by 0.25. So again, n is going to be 77. There's 77 terms. And now the hard part's over. Now, which formula do I use? In this case, they both work. And I would say the faster approach in this case is to plug in the first formula, because we have the first number, the last number, or the first term and the last term, and the number of terms. So I'm going to erase the rest of this. Again, I sincerely hope you're writing this as you're watching the video. Please don't eyeball the video. It's not as good as writing it down. So again, I go back and I say, I want to find the sum of the first 77 terms. That's 77 divided by 2. I take the first number, 1. I take the last number, 20, and I add them, and I multiply and divide accordingly. So again, you can do this in one step. If you want to do it with a calculator, that's fine. So again, I'll do this, 77 divided by 2. I'm going to multiply this by basically 21. This is going to be 808.5, and that is the sum. Great starter, great finisher. Example 6b, determine the sum of the following series. 3,645 minus 1,215 plus 405, all the way to 5. So again, the first step is, what kind of series are we looking at? So the first number, of course, is 3,645. And by inspection, it looks like you have to divide by a certain number. So let's pretend this is common ratio, which means I take some term divided by the previous term. Let's see if this works. So if I took negative 1,215 and I divided this by 3,645, this means R equals to negative 1 divided by 3. Now you want to double check this. So I can go back and say, well, what if I took 405 divided by negative 1,215? If you do that again, you should get negative 1 over 3 one more time. So this verifies that we found the first term. We found the common ratio, which means this is going to be geometric. Again, a geometric series means you're adding it up. Geometric sequence means you have a bunch of numbers separated by a comma. So I go back and I say, well, I need to find the number of terms first. So again, Tn is going to be a times r to the power of n minus 1. Tn, which is the last term, which I'll circle for you for your reference. Again, that's going to be 5, which equals to a, which is 3,645, times negative 1 over 3 to the power of n minus 1. To solve for n, the first step is to recognize the opposite of multiplying by 3,645 is to divide by 3,645. Again, if you think about this, on the left-hand side, this is basically 1 divided by 729. On the left, that's negative 1 over 3 to the power of n minus 1. So you want to go back and express this with the base negative 1 over 3. And you got to figure out 1 over negative 3 in brackets to what power will give you 1 divided by 729. So the first hint, of course, is we're probably thinking about a negative number. Let's see if this works. So if you look at this, not negative, sorry, I meant an even number, because on the left-hand side, you get positive 100 or positive 1 divided by 729. So a positive, I should say even number is probably what you're looking at. So let's be clear, in one sentence, if you take 1 divided by negative 3 in brackets to the power of 6, that will give you exactly 1 over 729. Again, this means when you have the same base, you create the exponents, and it's going to be 7. Now we can go back and say, well, let's find the sum of these 7 terms. How do we do this? I'm going to go back and continue here for you. So now I can go back and say the formula for a geometric series is a times r to the n minus 1 divided by r minus 1. So in this case, s of 7 is going to be 3,645. Let me grab a bit more space. Negative 1 over 3. I'll just put it back here. Multiplied by negative 1 over 3 in brackets to the power of 7 minus 1 all over negative 1 over 3 minus 1. Now, here's what I strongly suggest to everybody. Do this in one step. You don't need to do this in multiple steps. Just grab a calculator, which is one I'm going to show you right now. When you plug it in, this equals to 2,735. And that is the sum of the first 7 terms. I hope this makes sense.